Dai.
Ok. Bună seara și bine v-am găsit la o nouă ediție de Talks by Software și anume ediția cu numărul 154 și a doua ediție de când a început, de când a început pandemia fizică, ediție fizică. Mă bucur să văd câteva persoane aici cu care o să bem bere după, bineînțeles. Suntem live acum, a durat un pic mai mult pentru că am avut mici probleme cu audio, sper să se audă. E cu delay audio foarte mare? Ok, anyway, vom continua, poate echipa tehnică va reuși să rezolve ceva. În această seară avem două prezentări super faine și doi speakeri super faini, ambii speakeri autori de cărți de software development. Iar primul nostru speaker este Laurentiu Spilca, autor de Spring Security in Action în 2020 și Spring Starts Here în 2021. Este Development Lead și Trainer la Endava și o să-l rog să vină aici să ne... ok. Să vină aici alături de noi, că o să începem cu prezentarea lui. Dar, bineînțeles, mai avem și niște premii în această seară pentru oamenii care sunt aici. Avem niște desk mats, niște căști mișto și două cărți. Deci cine pune întrebări faine, automat intră într-o competiție pentru ele. Cu alte cuvinte, puneți o întrebare, noi vă luăm numele, vă punem numele într-un bol. Dacă sunt mai mulți oameni care au pus întrebări, tragem la sorți, dacă nu, vă dăm direct premiile. Laurentiu, Software Architecture, a series of pitfalls and trade-offs. Te rog, hai mare.
Thank you. So I hope you don't mind if I speak English.
We have completely forgot about that.
Because we have a lot of followers online and we don't know how many of them understand Romanian. So let's continue in English. And of course, our subject for today is a series of pitfalls and trade-offs. So I prepared for you about 5, which is kind of difficult because in software architecture and software development in general, there are too many trade-offs and pitfalls that we are doing throughout our process of development, and choosing 5 of them or only 5 of them is not easy. But I only have 30 minutes at most, and I usually tend to talk a lot. If you have questions, don't forget that you can ask questions during the presentation, so you don't have to wait for up to the end. Just raise your hand. For the guys who are online, I'm not sure if you can ask questions, or maybe the moderators here can tell me if I have any questions from online. With that being said, let's start the presentation. And I will just skip very shortly over this slide because it's only presenting ways in which you can connect with me. There are a few. I have a YouTube channel, quite known today. You can find me on my blog, or you can follow me on Twitter or on LinkedIn, and we can discuss there. And of course, you see my books on the left, and one of them, the Spring Security in Action. I will give this copy to one of you guys who are here. Very soon, I will have copies from my second book, and hopefully in the next event, if you participate, I will share even more than one copy of that book. Catalin, I think here also has a copy of his book for you. So. Yeah, the first one, they are not necessarily in a given order, so I don't want you to believe that one is more important than the other. It's just a random order, but they are kind of trade-offs and pitfalls that I tend to more and more find often in recent projects that I'm consulting, because I work as a consultant, so I do see a lot of projects and I do get a lot of questions from different. And maybe the first one we can note here is the proof of concept curve. What's the proof of concept curve? So when you start a new application, a new capability, a new implementation, in many cases we start with proof of concepts because it's the easiest way in which you can research how to implement that specific thing, which are the best choices in terms of technologies, the best choices in terms of approaches, architectural approaches. We don't know them all. The industry tends to be very fast and tends to evolve very fast. So, maybe 4 or 5 years ago, we didn't have at all Kubernetes, Istio, stuff like that. We worked with virtual machines. Earlier than that, we were working with directly maybe bare metal. Things evolve very fast, and it's pretty difficult to stay up to date with everything that is out there. So we start with proof of concepts to find out what's the best choice. And the proof of concepts were, first of all, one of the important things is that it's only used, and you should only use it for research purposes. Once a POC is done, you throw it away, you start from scratch, but that's usually not what happens. But when you start a proof of concept, you know that you don't follow clean coding rules usually. It's not meant to be fully functional. Okay, sorry. It is not meant to be fully functional. It's only for research purposes. And well, when we start working on that, usually you have a conversation with your client and you have to agree all those things. And it turns out that you usually tell them how it is, how it goes, and they say, sure, it makes sense, it's fine, we're going to garbage all that code and then we'll start from scratch. But 2 months later, when you finish your POC, it's something like, oh man, we can't just throw away 2 months of work for a full 10 people team. And if you fall into that trap, and so if you continue over the POC, then the technical debt has this curse where you can only, it's very difficult to get on a descendant curve of technical debt. You will usually go on an ascending curve. At some point, you will end up with a messy application. So one of the most important trade-offs that you shouldn't make is using a POC. So the lesson learned from here is don't reuse a POC code. Very important, keep that in mind. If you start with a POC, you throw it away at some point, everyone has to understand that, and you start from scratch. Never use that code. So the second one, the Microservices Illusions. I'm not sure how many of you started working on microservices, because actually this is a quite misunderstood concept. Many people consider that, contrary to the popular opinion, if you have a Spring Boot application that has some REST endpoints and changes data in a database, that's a microservice, which is wrong, of course. But let's say that we discussed here about real microservices and service-oriented architectures. And of course, you have that idea that's it's been popularized throughout the time, last 4 or 5 years maybe, that the microservices architectures are the best and they solve all the possible problems. But one of my favorite books that you have here is the Monolith to Microservices by Neumann. This is a short extract from it, where Sam says microservices are not the goal. You didn't win by having microservices. And the idea is that the microservices as an architectural style, same as all the other architectural styles, they apply to a certain kind of solution. So you might have a solution where a monolithical approach applies better, a solution where a service-oriented approach applies better, a solution where microservices is the best choice. And in most cases, in bigger systems, you have a merge of all of them together. So you can't say there is one architectural styles that solve all the problems. And yeah, of course, you know that you get, and if you read books about microservices, you know that you get a lot of good stuff like the possibility to be polyglotic, the possibility to have independent versioning, independent deployment. But you also get a lot of problems with it, which is the communication between the applications, which now, the network is not 100% reliable, and that's a rule of thumb in any kind of software-oriented architecture or cloud development. And yeah, in the end, the image that microservices is a unicorn and then a monolith is some kind of a devil is of course wrong. Why did we think historically that monolithical approach is wrong? Is because first of all, at the beginning of the modern development era, say about the 90s, there were no principles, there were no design patterns, there were no rules that we knew to make our systems better in terms of from the low-level coding up to the business patterns that we apply at the process level. And the reason for that is we didn't have those because we didn't have time to discover them. They were discovered throughout the time. And it ended up that a lot of applications who are older now, they are monolithical and they haven't been developed in a clean way. So they became kind of an image of what's wrong. But the idea is that a monolithic application can be clean, can be clean in terms of code, can be modularized, can be architecturally written well, and there's no reason to make a link between something that's evil, unclean, wrong with the monolithic architectural style, which applies very well again in a lot of situations. So the lesson learned from this is clearly analyze properly what your solution is from the architectural point of view. Choose the style that applies best for your architecture, and very important, make sure that you think in terms of emerging, which means that nowadays solutions are continuously implemented and they are growing continuously, so you need to make sure that the way you choose your approach is such in a way in which you allow for extension in the future for many years. Number 3, I let non-functional for later myth. A lot of applications start with the functional in mind. Now, functional is basically the business cases. I want to before discussing this aspect, let's agree on what non-functional is, because I don't want to have misunderstandings here. So performance, security, maintainability, testability, they are software qualities, and we consider the non-functional testing qualities, which means that they are not related to the functionality, the business functionality you implement. Well, while they are not related to what the user needs to immediately use, they are very important, and not taking them into consideration from the very beginning of designing your software architecture is a very, very bad choice. And I've seen, and especially with maintainability, security, and performance, I tend to see more and more softwares that they have been implemented, not taking at all into consideration this, and they end up after a couple of years of implementation with a lot of messy code, unsecured. I think a couple of months ago I've seen latest a web application that had only the first route secured. You think that something like this doesn't happen? Well, it happens, and it wasn't a small company. Performance as well, which is very difficult to improve afterwards because it depends a lot also on how you write the code, and of course maintainability, which makes your development curve slower, and at some point, from the economical point of view, it makes that your implementation is not profitable anymore. So yes, the idea is that even if you tend to think about more of implementing the business cases, take also into consideration the non-functional aspects, such as the security. So whenever you hear someone saying, don't trust security, let's implement that stuff because we don't care, nobody will hack us, you will always know that someone there might listen to that. And the problem is with these kinds of security issues, for example, is that the consequences might be severe. And I'm talking about here legislation as well as the probability of having users affected in terms of even having their bank accounts emptied and stuff like that. Of course, maintainability, a very important aspect. You don't want your code to look like a big garbage trunk. If it happens, again, the reverse of that is very difficult because we live in a universe where that's chaotic. It relies on entropy, and that means that it's easier to go from organized to chaos than chaotic to organized. So that applies also to software. So whenever you see a code that's messy, it's very, very difficult. The messier it is, the more difficult it is to turn it back. And at some point, it's even easier to rewrite completely the solution rather than turning it back into a clean solution that will allow you implement and solve bugs easier later. So yeah, I already said that the development velocity continues to have a descending slope, and of course, developers are frustrated, continue to be more and more frustrated, and you know that usually what happens is that when a developer is more and more upset, at some point it will completely leave the team of the company. And if you are in a company that wants to preserve their developers, one of the things you would like to take into consideration is allowing them keep the solution clean, because later they will be frustrated with the solution they or others before them implemented. And that's a very good lesson learned throughout everything. Non-functional is as important as functional. You should take it into consideration from the very first start of implementing a solution, and you should allow your developers to continue taking into consideration non-functional every sprint, saying the work agile, anytime, every day. Number 4, the Mirage of using the latest technologies. That's a nice one, because I think it was yesterday or the day before that I said I just updated Java 17 in production. And I think that I'm smiling now because and the latest Spring Boot, yes. So I just on one of the projects I'm working on, I just updated Java 17, and I felt very, very nice, because everything that's new in software is usually hot and sexy, and you of course want to use those hot and sexy technologies in your app. Even though maybe you don't get necessarily a lot of, at least on the short term, a lot of good stuff that will improve a lot your application. I do love Textbox, however, so they helped me in refactoring, I can say, a lot of long queries that I have in one of the services, and now I simply copy paste them when I want to put them in PLSQL. So I'm really glad to Textbox. I know that I will find other stuff in the future useful, but the idea is that I don't want anyone to believe that always what's new is necessarily good. So in case of Java, when I say Java 17, you know that you rely on a language that has 25 years already. So it's 25 years old, it's a lot of people knowing it, it's a lot of people using it. But if you start on a specific technology that's not known at all, a new framework, a new language, and I've seen that a lot of time, people using that kind of Oompa language that's now very hot, and then after some time you don't find the developers anymore that want to learn that Oompa. I replace that because I don't want to say, I don't know, Scala or Ruby or something like that. I don't want to refer to a specific language. But I've seen situations in the past with real, of course, technologies and languages where architects decided to start on with that specific technology, finding it bulletproof of the future, and then they discovered a year later that it's more and more difficult to find people learning it, that the community is not so large. If you have a problem, you search it, it's rather more difficult to find a solution on Stack Overflow, and all of us rely on Stack Overflow, of course. And what I want to say is not necessarily you don't have to use new technologies, that's not right. But you have to be very careful when you choose them. So don't choose the technologies only because they are new, choose them because they have a large community, choose them because they have a big probability to become valuable, choose them because it makes developers happy on a long term, not on a short term. Take all these points into consideration when you choose a specific technology, and don't rush into choosing one just because it's new and it seems that now it's on the way. The over-engineering scene, a lot of cases where you just implement stuff because they might be used at some point. So I've seen, and I will tell you a story, a few months, maybe at most a year ago, I was consulting a project where they decided to implement, the development team, whatever, they decided to implement an authorization server instead of using an existing solution such as Keycloak or Azure AD or Cognito in case of AWS. You have a lot of solutions nowadays. But they decided to start from scratch a new one because they might use something different at some point. Well, it's very fun because they invested a lot of time, and I mean months of work of many developers, many FTEs, to implement that, and at the end they found out that it's not useful for them. But nobody asked, why did we start that? And when somebody asked why did we start implementing that component, nobody had an answer. Well, it seemed that we will need to use it in the future. But there was no concrete analysis on why and where would that be used. And of course, at some point they just decided to garbage it and start with a public, not a public, sorry, with an existing solution, an open source solution. I think they chose Tito, but I'm not sure. I'm not 100% sure. But the idea is don't implement stuff because you might use it in the future. And sometimes it even happens that this comes from the users. They tell you, well, shouldn't we implement that because I think at some point we might use it. The idea of Agile is putting them into a backlog and taking them when they are really needed to be implemented. And don't start implementing stuff without properly analyze if they are useful or not. So you should architect on abstractions. The idea with the story about the authorization server they implemented. So you might abstract, but not too much, just at the point where you have what you need at the moment, and not necessarily at a long start, on a long term in the future. So think on the near future, not necessarily on a long term future, because you don't know what will be in 5 years from now on. And yeah, when anyone asks you in a technical interview how you see yourself in 5 years, probably you can't know that, so it's not really a question. Wasn't there a fourth? I think it's a mistake. It was the fifth, isn't it? Yeah, so my mistake in the presentation. And with that being said, I conclude my presentation. We didn't have questions, but you had the opportunity. You have again the opportunity to ask questions if you want. Otherwise, you know precisely how to follow me and discuss later in case you need. Let's see, any questions, anyone? Please, there.
1 second.
Hello, very nice presentation. I would have a curiosity. Would you recommend a combination of a relational database with a NoSQL?
In a software system, definitely. There are cases where some capabilities should rely on a relational database because of the advantages, say, it brings with consistency, while other components, other capabilities would need to rely on a non-relational database for, say, the way it structures the data. For example, if I have some capability that needs to represent the data as a graph, I might want to use Neo4j because it's easier to scale it, and it's easier to implement my algorithms based on the way Neo4j represents the data behind the scenes, the data model. While in some cases, I might find it easier to just have relational databases. They offer some consistency, they are more difficult to scale, they are wider known by the developers. They bring advantages and disadvantages either of the sides. Combining them in a system might be a way to go.
Thank you.
Please.
What are the aspects you take in consideration when you choose between a microservices or a monolithical approach?
One of the, well, that's a difficult question actually. You asked the difficult questions. I should have said no difficult questions. But, well, first of all, is the way you deploy is important. That means if you will have, if you know you will have a large system with a lot of business domain actions, then you already go to a service-oriented, I'm not necessarily saying now microservices, service-oriented architecture. Then if you will have a large enough system that you plan, say, I have some examples like say Netflix, which is very large behind the scenes, and you know that you might want to segregate the data model as well for each business case, then you will go probably up to microservices. Performance as well, the ability to scale faster the applications, but that applies also to service-oriented architecture. So because it's not necessarily that if you have services and they are small, they are microservices now because they are services and small. So that's why I say
monolithical approach wouldn't allow you to
the monolithical approach wouldn't allow you to scale easy. It might, unless you have statefulness, which is very often case in a monolithic applications, but you might have a non-stateful monolith. And then the most difficult part of scaling it is, of course, the fact that usually growing bigger as a process, it also starts slower, which makes it more difficult to deploy in a container, so it makes it more difficult to scale at some point because you wait more time for it to scale.
You will be able to choose which parts of that monolith to scale.
You can't choose which parts to scale. If you want to precisely choose one part, then you necessarily need to go to a service-oriented. And again, up to microservices. So, but let's say service-oriented because again, I don't necessarily want to say that you need to have microservices to be able to scale. You can scale a service-oriented as well. Super, thank you very much. Any other question?
So you've presented us 5 pitfalls, right?
5
Yeah.
trade-offs, pitfalls, that's one way.
Can you present us a 6th that you consider the most controversial?
Wow. I should have said no difficult questions. So I only thought about 5, and at this time it's quite late for me. Let's do like this. Find me on Twitter or LinkedIn afterwards, and I'm now going to drink a beer and think about the 6th. So, sorry.
Awesome. Any more questions? Maybe in the back? Because we have some prizes to give away as well. Okay. Okay, so no more questions. Thank you very much, Laurentiu, for your presentation.
Thank you for the questions. Thank you for being here. Hope to follow me on LinkedIn, Twitter, YouTube, and let's discuss further. I will answer you.
And of course, on the Talks by Softinator Facebook group, or on the LinkedIn group. We'll take now a 10 minutes break, and then we'll come back with Catalin Tudose, author at Pluralsight and Manning, Java and Web Technologies expert at Luxoft, about building the architecture of a test pyramid strategy. The next presentation will be in Romanian, in English, okay, in English as well, so stay tuned. We're going to stop our live and then restart it again, so stay tuned on our channels on Facebook, LinkedIn, and YouTube. See you soon.
Mai